Hello, how you doing? Have you seen how easy it is from text documents to create embeddings and then insert them into a vector database? Well, if not, then watch along with me for the next few minutes and I'll quickly get you up to speed. Okay, let's get started. Let's quickly review embeddings. Embeddings are vector representations of data. In our case, text data, but it could be any data such as images, audio, or video. There are specialized LLMs, also known as embedding LLMs, that take in data and generate embeddings. In this example, I'm showing an embedding LLM generating an embedding from a text document. Again, an embedding is just a sequence of n-dimensional vectors. In this code example, I will use an OpenAI embedding LLM to create our embeddings. We will save our embeddings in a vector database. I'll be using the Pinecone Vector database in this example. If you want to recreate this example yourself, you'll need an OpenAI API key and a Pinecone Vector database API key. Quick note, I have a series of videos that will deep dive into the Pinecone Vector database. Feel free to check this playlist out if you want to go deeper into this topic. But for now, I'm going to keep going. So now, let me go into the code. All of the Python dependencies are listed in the README file checked in with the Python code into GitHub. The GitHub URL is in the YouTube description. At a high level, you need to download a Pinecone package as well as multiple LangChain packages. This Python example does use the LangChain framework. I include two helper Python scripts for creating and deleting Pinecone index. The first is for creating the Pinecone index. This Python script creates a Pinecone index in the Pinecone cloud service located in US East 1 region in AWS Cloud. I'll need to run this script first so I have an index in Pinecone available for this example. The Pinecone index name is LangChain-embeddings-demo. When I create this index, initially it will be empty with no vectors. You should note, I'm creating this Pinecone index with a vector dimension of 1536. This is not a random setting I came up with. This 1536 dimension value is the same dimension of the vectors generated by the OpenAI embedding LLM I'm using in this example. These must match for this to work. Earlier I mentioned that I use one of the OpenAI's embedding LLM. But you could decide to implement this using a different embedding LLM. And if you do this, find out what the dimensions are of the output vectors and use this as your dimensionality value when you create your index. The second Python script is the Pinecone delete indexes.py, which will delete the Pinecone index. As I was working out this Python example, I found I needed to create and delete the index several times as I was troubleshooting. These two scripts were super helpful, so I went ahead and decided to include these for you as well. Quick note, I go into the create, delete Pinecone scripts in more detail in the Pinecone Vector database playlist I referenced earlier. Again, check this out if you want to go deeper into this. There are two more Python scripts I included in creating embeddings that I used as I was working out this code example. The first creates embeddings from hard-coded strings. Again, this is something I included as an extra example for you to look at. The second creates an embedding for just one text file. I shared this one as well as another example. So the Python script I really want to go into is the LangChain-embedding from directory.py. This Python script will create embeddings for the 5 text files residing in the Coastal Marine Synopsis directory. This is the one I want to talk to next. The 5 text files are shown here. They each have a marine forecast content in the files as of November 29th, 2024. Just so you can quickly see what text we're using in this example, I open up the text file flowergardensanctuary.txt. This file contains a marine forecast for this part of the Gulf of Mexico on November 29th, 2024. The other text files cover marine forecasts for other parts of this large body of water. Okay, so now let's look at some Python and LangChain. The Python script I'm showing you next will read each of the 5 files and create embeddings, and then we'll insert them into the Pinecone index. So in this Python script, you can see all of the Python dependencies imported. The first thing I do is set the Python OpenAI.api key with an environment variable configured with my OpenAI API key. Offline, I have set up environment variables on my Mac for both the OpenAI API key as well as my Pinecone API key. See the README file for more details on this. Next, I initialize the Python embedding object with an OpenAI embedding model. You can see I specify the model text embeddings ADA002. This OpenAI embedding model generates vectors that have 1536 dimensions. Again, when creating my Pinecone index earlier, I also configured it with the dimensions of 1536, knowing that I'd be storing vectors with the same dimensionality. Next, I load all the text files containing coastal marine forecasts from the directory named Coastal Marine Synopsis into the Python documents object. After this, I use a text splitter object to split the documents into chunks. These chunks are stored in the Python object split documents. Next, I connect to the Python index using LangChain's Pinecone wrapper. Then I add my split documents to the Pinecone index. What happens here is the embeddings are generated from the split documents and then inserted into the Pinecone index. You can see that LangChain abstracts a lot of this out for us in these 2 lines of Python code. So running this, you can see the script generates and saves the embeddings in Pinecone. Here's a screenshot of the console after I run this Python script. Now that I've run the script, I should have vectors in my Pinecone index. If I log on to Pinecone and navigate to my Pinecone index, I can see that my vectors have been inserted. Here's a screenshot of the Pinecone index. Note, you also see the index is configured with a dimension of 1536. Next, looking at the first vector in the index, this vector has 2 metadata attributes. The first metadata is the source. This is the file that the text block originated from. In this case, the name flowergardensanctuary.txt, which is the name of the file that was used to create this embedding. The second metadata attribute is the text. This is the actual text block used to create the vector embedding. You also see the vector itself, which has dimensions of 1536. Okay, so now you see how easy it is to create a Python script that will read in text files, split them into chunks, create embeddings, and then insert them into a vector database. In this code example, we use an OpenAI embedding model and the Pinecone Vector database, along with LangChain. By using LangChain, it makes it easy to swap out to other embedding models or other vector databases, so this same code example would generally work with other embedding LLMs or other vector databases. Okay, thanks for watching. This video, along with all the other videos in this playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing, we all love technology, and we're all excited about all the innovation with the cloud and machine learning and AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing. Get out and move your body. And if you do, let me know in the comments. I want to hear about it. And with that, have a great day. Thanks.